Hello friends, we have been exploring the neighborhood of our solar system and we have explored many systems like red dwarf systems or yellow star systems in the close vicinity. We have been to the closest star Alpha Centauri and we have been to many red dwarfs in the close vicinity. But today we are going to visit a very strange object and also in the close vicinity, and therefore this is going to be very interesting. So friends, what is this body? This is called Van Manen star, and it's a white dwarf, and that is what makes it so interesting. So let us examine what is this Van Manen star and what are the secrets that this white dwarf star is holding. Let us get into our imaginary spaceship and let's get into orbit of this star to examine it up close. So here we are, and as you can see, this is rotating rather fast. So the angular momentum of a white dwarf is very fast. We will actually explain everything about this star and white dwarf in general. But let's begin with what is so special in this. Well, this is close by. It is only 13.9 light years from Earth, and as I said, this is a white dwarf star. White dwarf is a very peculiar type of body that exists in the universe, and that is that basically whenever there is a yellow star, it will burn out into a white dwarf. So it is basically the leftover core of a yellow star, a sun-like star, and that is why it has very peculiar structure and very peculiar properties. And when it comes to this particular star, it was probably the size of sun, because anything bigger will end into either a neutron star or a black hole. So a medium sized yellow star, basically when it finishes its fuel, it burns hydrogen and convert that into helium, and once helium get converted, and when the core is not hot enough to hold the outer bodies, the core is left out as a white dwarf, and this is what this Van Manen star is. So if you look at other strange properties of this particular white dwarf, it is rather small. It is only 16,000 kilometers in diameter, roughly about 17,000 kilometers in diameter. And if you want to compare this star, we call it a star. Usually stars are big, but when you call this as a white dwarf star, the size of this is actually much smaller than Earth. You can actually see the Earth is bigger and this is much smaller. So this is a very compact body of material and mass and very high gravity, and a leftover core of a yellow star type star system in the past. And that is what it is so peculiar. This is something which is, it does not generate any heat. There is no reaction going on. It just retains the heat which the star had earlier and cools down gradually as it exists. So this is the end of life of a mid-sized star, and this is what we are examining in Van Manen star, which is very close by. Now another peculiar property of this is that it is moving very fast. The speed at which this is moving around the galaxy is 263 kilometers per second. 263 kilometers per second. If you multiply and find out the speed of this, it's almost like 950,000 kilometers per hour, almost a million kilometers per hour. That is the speed of this particular star, and it is moving around the center of the galaxy at this speed. Now if you want to compare that speed with the speed of sound, it is many times the speed of sound. I mean, it is probably broken the sound barrier maybe 1,000 times over. So this is moving at such a breakneck speed. We don't know why it is moving so fast, but it is moving very fast, and it is also rotating quite rapidly around its axis. Now that can be explained by the very characteristic of the white dwarf star. Basically, when the mid-sized star basically runs out of its fuel, it actually leaves outer layer. It sheds the outer layer into space, and we can see that these layers are shed into space, and gradually this material actually becomes a gas, leftovers and all that. And this is also called a planetary nebula. So in case a new reaction, new birth of star happens, this material is again reused in making some portion of the new star and some portion of the planets that will form in future. However, around this particular star, first of all, it is rotating very fast. So let me explain why the star rotates very fast. It's like when the star is very big, it rotates about, let's look at the sun. It takes about 12 days to rotate on its axis. But when the size is reduced, then obviously when the size is reducing, the speed increases. So that is why white dwarf stars rotate quite fast. And this is also moving very fast. And probably that is the reason we don't see any planets or any nebula left over around the star, because of this breakneck speed, everything else, all the material has been left behind. So this is something very peculiar about this one Manen star, which is very close by. Now, what will happen to Von Manen? Von Manen is a typical white dwarf, and if no intervention happens to white dwarf, then it will continue to shed its temperature, and it cool down very, very slowly over trillions of years. Now, the universe is only 13.4 billion years, so the cooling down process will take several trillion years. So since the universe is also young as compared to the cooling down period that a white dwarf would need to cool down eventually, so we have not seen what happens to the white dwarf if it does not collide with anything, it does not start attracting other bodies. But the hypothesis is that over trillions of years, it will cool down in something called black dwarf. Now, as you know that the core of the star of a white dwarf is a big ball of carbon. We have covered that in the past video, and the carbon is because of the pressure and heat, it is crystallized. So essentially a white dwarf is nothing but a big piece of diamond, crystallized form of carbon, and it is retaining heat from its past, and it will cool down gradually. So what will happen after trillions of years to a white dwarf, including Von Manen star? It will turn into a black dwarf. That means it has completely shed its temperature. Now it is cooled down into something called black dwarf, does not emit any sort of radiation. So this is the eventual fate of these kind of stars that is hypothesized, because the universe is quite young. We have not seen any white dwarf cooling down into a black dwarf, so that is something in future. So Von Manen, if nothing happens to Von Manen, it does not collide with anything else in the near future or later on, or it does not absorb more material, then naturally after trillions of years it will transform into a black dwarf. So this is something which is close by. I think it is quite interesting to know that we have a white dwarf star so close by and moving so rapidly, moving around the galaxy so fast. It is worth exploring, and maybe we should send some probe to explore, because that will give us more understanding of how universe works and what will happen to these stars which they eventually once the yellow star like our sun dies out, what eventually happens to them. It will be very, very interesting to learn about that. So friends, if you know more than what I have told you, don't hesitate to share your comments, and I will respond to each and every one of your comments. And as always, thanks for watching, and I will catch you in the next edition of Multiverse.